All right, the last thing we're going to do in this section is talk about converting equations from rectangular to polar and vice versa. The equations for conversion stay the same, but we can pull from any of these four equations during either one of these processes. So the first one we're going to look at is x plus 2y plus 3 equals 0. I will say that a lot of times when you're converting from rectangular to polar, that you'll use these equations because you can just replace x with r cos theta, and you can replace y with r sine theta. The goal when you're converting, if you're trying to get something in polar, you want to make sure that the only variables in your answer are r and theta like we see here. So technically we already accomplished the goal, but what you want to do is always try to solve for r if you can. Get r by itself. So that's what we're going to try to do. Let's move this 3 over since it doesn't have an r. And then now that both of these terms have r, we can factor r out. Okay, and then, since this is multiplication here, we can divide. And we are done once I write this down. Okay, so that's polar form right there. Alrighty, for part B, we are going to look at x squared plus y squared equals 6y. We could do the same thing and just replace the x's with r cosine and the y's with r sine, but there's an easier way if we remember this formula as well. So x squared plus y squared is equal to r squared, so we can make that substitution immediately, just make this r squared. And then over here we have a y still, we need to get rid of the y, so we'll use this formula. So y becomes r sine theta. And we're basically done, right? We have just r's and theta in our answer now, and that's what we wanted, so we're pretty happy with that. But said you want to try to solve for r if you can. And if you have r on both, if every term has an r, you can actually divide it out. So we can divide both sides by r, which gives us r is equal to 6 sine theta. And that is our final answer. I do want to show you something that is pretty cool on the calculator. We can plot stuff in polar coordinates. And I'm going to do a whole video on this, but if you go into mode, you want to switch your mode over to polar. So down here, you're going to go over to POL and hit enter. So it's on polar. And then you're going to go ahead and go to y equals, but now it should automatically say r equals. And you're going to type in, let's type this in and see what it looks like. So we have -3 divided by parentheses, cosine theta plus 2 sine theta, close parentheses twice. And I'm going to hit graph and see what happens. I might have to mess with the window. All right, there we go. It's a line. Does that make sense? Was this linear? This was linear, right? Couldn't we rearrange this equation and get y by itself if we subtracted, let's see, what would y be? We would subtract x, we would subtract 3, we'd divide by 2. Look, it's like y equals mx plus b form. So it's a line with a negative slope, which matches what we're seeing here. So that's pretty cool, right? Okay, so you can check these graphs out. It's interesting. And number 2, we're going to do the opposite. We're going to start with polar, and we're going to convert over to rectangular. Okay, so We want to try to utilize these formulas. If you notice in the formulas, the only trig functions are cosine and sine. So if we have a trig function in the problem, we want to try to write it in terms of cosine or sine. Secant we can definitely write in terms of cosine, right? Because they're reciprocals of each other. So I can write this as r, and then I could write secant as 1 over cosine. That just makes this r over cosine, if that makes sense. Equals 4. And then you can multiply both sides by cosine to get rid of the fraction. So we get r equals, right, if we multiply by cosine over here, bam, those cancel out. So we get 4 cos theta. So we're getting kind of closer to being able to use a formula. In order to use this formula, though, it needs to be r cosine, but we don't have an r in front of the cosine. So what we're going to do is force it to have an r in front of the cosine by multiplying by r. So multiply both sides by r. If we do that, r times r, that gives us r squared equals, and then we'll have 4r cos theta. And then we can make some substitutions to get x and y variables in here. So what can r squared become? Well, it can become x squared plus y squared, right? Because we see right here that r squared is equal to x squared plus y squared. The 4 is going to come down, and then what does r cos theta equal? It equals x. So that becomes x. And now we are done. Okay, so there's our rectangular equation. We know we're in rectangular form because we just have x's and y's. You're not allowed to have any r's or thetas at all left over in rectangular form. All right, one more. So r equals 4 cos theta plus 2 sine theta. We're going to use the same technique we used back here where we multiply both sides by r. So that means every single term gets multiplied by r. We're giving us r squared equals 4r cos theta plus 2r sine theta. And then we make our substitution. So r squared gets to become x squared plus y squared. R cos theta becomes x, and r sine theta becomes y. So there's our equation there. Alrighty, that's it for this one. I was going to say, I guess the reason I paused, if you noticed, I was going to say it'd be kind of hard to graph this one on the graphing calculator, right? Because it's not super easy to solve for y here. It's possible, not definitely possible, but it would require some work. But you could type this in the polar form, right, and see what this graph looks like. That might be something interesting to try.